So I know you've all had a long day of learning and having information pounded into your brain, so I'll try not to teach you too much. Is this going to change it? Here we go. Excellent. So I am here to talk to you about building a business using one of these future stacks, subtitled Using Microservices as a Means to an End. Because so many of us can relate to this very popular Twitter image that I stole from the internet, because I stole a lot of images from the internet. But when I saw it, I thought, oh, I'm definitely going to be using this in a talk, because it's so resonating with so many engineers right now, myself included, right? On-call is a very difficult situation for many tech teams, especially tech teams at small companies, at startups and growing companies, right? We're in this brave new world of technology, and because we're at the edge of this brave new world, we're constantly stepping over it into the error domain and having issues, right? And so a lot of our time, I think, is spent thinking about how do we get out of here? How do we use products like New Relic and, et cetera, to get out of this land where we're constantly being paged over issues big and small? But I think it's sort of fun to ask ourselves, before we think about how we get out of here, ask ourselves, how did we get here in the first place? So this is going to be a perspective on how we ended up in the modern application trends. Actually, it's really my perspective. So I call it a people's history, but it's really just this person's history. Sort of my muddled impressions from the past roughly 20 years of computing evolution that we've been going through. So, in the beginning, there's always a beginning, there was the three-tier application architecture, which anyone who wrote sort of business application logic code 15, 20 years ago, you were probably working in an architecture like this. And there may have been some network, right, between that presentation layer, application layer, data access layer. But it really wasn't much of a distributed system, right? Distributed system is one in which the failure of a computer you didn't know existed can render your own computer unusable. And as a developer, you probably knew about all those computers. Maybe you didn't know about your client's computers, but if they failed, you didn't care, right? You cared about the database and you cared about your application servers. Well, of course, now we're in this brave new world of distributed computing, right? What happened? Well, Moore's law sort of just could not keep up with the growth of data we needed to process, the growth of products we needed to build, the growth of people on the internet, people using technology. So what happened? What did we do? Well, this company came out in the early 2000s, Google, and they started talking about how instead of using supercomputers to solve these big, big problems, they were buying just tons and tons of commodity machines. And they were doing things like building their own distributed file systems and building concepts called MapReduce, right? Writing paper like Google MapReduce. They wrote about Bigtable. And everybody read these papers and they're like, oh, this is really cool. This is a good idea. This makes sense. And so we all copied them, right? Hadoop came out. You see Amazon write their paper about DynamoDB, and then you see Cassandra come out on the tail of that, right? So this distributed computing movement really starts to heat up significantly in the late 2000s. In fact, I wrote my own distributed system, bespoke distributed system for an application that needed some data distribution in the late 2000s. It was very, very common for people to do that. But it was still mostly storage data-related distributed systems written by systems engineers. Okay, so that's track one. Now, track two. Amazon Web Services comes out in 2006, and Heroku comes out in 2007. And this was mind-blowing. Maybe some of you predicted it. I certainly did not predict something like this happening. And when it came out, it was awesome, right? All of a sudden, we had gone from a place where, it used to be, especially if you were at a big company, if you wanted new hardware, it was a cycle. You had to get it approved. You had to wait for somebody in ops to rack that hardware for you and configure it and all of that. And now you can go onto AWS and just get it super quickly, super easily. So I like to say that developers suddenly had the keys to the kingdom of what had been really ops-only territory for most companies. Which means we decided to do something crazy, and we created this movement called DevOps, right? So now, okay, look, the DevOps movement is not just because of AWS, but I do personally believe that developers having really easy access to spin up compute themselves, right? To configure compute themselves is a huge part of the reason why the DevOps movement came about, right? Developers could just do it, and so they did. But they're not operations specialists. Okay, so we've got distributed computing, we've got the cloud and DevOps. Now, what else? Right, okay, so finally, we all started building these startups in the middle of the 2000s, late 2000s, right? And it is a good idea to build a startup on a monolith if you can, because it's easy, right? I'm actually a fan of, like, unless you've got a really, really good reason to do it, it's totally cool. Build it on Ruby on Rails or whatever makes sense for you. But unfortunately, if your startup is actually successful, then you've got a monolith, and that's a real pain in the butt. How did we figure out how to get out of monoliths? Well, fortunately, like, again, compute was easy to access, network was easy to access, people are sort of familiar with distributed systems, so we decided to do this crazy thing called microservices. And so now, instead of one complex centralized system, we've got many, many, many little fairly simple systems, but a really complex overall system, right? We've got a distributed system that was written by application developers. Now, anytime you start to get new application architectures coming out, immediately you get the wonks. I'm sure they're very nice people, right? But you get the wonks coming out and telling you how you should do it, right? Oh, it's an application architecture. Well, here's your 20 principles that you must follow. Here's all your best practices. And these are all very good best practices, by the way. So, to sum it up, what happened, right? We had distributed systems really come out, be the cool thing for everyone to do. We have developers pretending to be ops folks on unstable hardware in the cloud. It's better now, but it was pretty unstable for a while. And we had all these monoliths that were slowing us down. So we evolved into services, which meant that we've got application developers writing distributed systems on unstable hardware without operations specialists, all under conditions of scarcity, right? Should and must are really hard to hear when you are 20, 30, 50 developers just trying to build your business, just trying to make things work, just trying to move forward, right? I don't really love hearing talks about how you should and you must and you absolutely will. And if you don't do this, all those pages you're getting are your own damn fault, right? I'm not a fan of that because I can tell you personally, having been in this situation, scarcity of attention is a really big thing when you're trying to run a tech team at a startup. You've got a million different competing priorities. And it can make you feel, frankly, kind of dumb, right? You don't always make the best decisions. You're just trying to, like, move the ball forward, get that next release out, get that next feature out, get to the next funding round. So, you know, we've got, like, diagrams like this from Martin Fowler, which is, like, very interesting, right? He talks about the inflection point at which microservices make sense over monoliths. And I think this is very useful. And I think it's very useful to point out that you do not have to have perfect conditions to reach the inflection point. You don't have to have implemented every single best practice or principle of microservices to make it still worth doing over working in a monolith. Okay, so on-call is tough. We've gotten into this brave new world. We're running microservices. We're a small company. How do we move forward from here? So what in the world are we trying to do? Anyway, what is our goal with all of this, right? So I don't know about all of you, but my goal as the CTO of a startup is to grow a business. I want to build a business that's successful. And I want to do whatever I need to do with ethical constraints, of course, to build that business, to make it successful. That's my goal. And so when I think about how do I have a tech team that is supporting that goal, I want my tech team to be able to iterate and respond quickly. I want them to be able to build new features quickly. I want them to be able to test things out and learn from them. And when something goes wrong, I also want to be able to respond quickly to problems. I also want to understand the state of things at all times as much as possible, right? Both to detect unseen issues, unknown issues, as well as to detect opportunities, right? To understand my customer and their behavior with my systems. So we're going to break these two things down and just go through a few things that I believe are valuable when thinking about dealing with a microservices environment that's imperfect, right? So iterating and responding quickly, rapid development and incident management. I believe that a keystone habit of great engineering teams is that they release frequently. And I'm not going to talk to you guys about continuous deployment. There are a lot of people that have given great talks about that in the past. I've been many conferences. I'm not an expert in it anyway. But I do think that this is a really important thing to keep in mind as you're developing a team. You need to be releasing frequently. And so there's all sorts of things about continuous deployment, automation, yada, yada. But there are some things that we knew how to do that we've kind of forgotten as we've gone to the more modern practices in continuous deployment. Some things that I think are still pretty important, things like testing. So sometimes you go to conferences, especially with conferences about monitoring, and people say, oh, well, you don't need to write tests anymore because you've got monitoring. Your monitors will tell you when things are broken. Look, testing. We test to gain confidence that our system is doing the right thing now and later. I stole this slide from a friend of mine who gave a great talk on distributed systems testing a few months ago, right? Testing is a good thing. Your customers should not be treated as guinea pigs all the time. I mean, maybe you're A/B testing on them, but hopefully you're not just putting features that you're not even sure whether they actually work at all in front of them. Testing is important. If your developers are not writing tests, they are not going to be able to modify the code in the future. I feel like this is an obvious topic, and yet it's one that I've started emphasizing because I think it's kind of fallen a little bit out of favor, the idea that we should be testing. I'm not saying you have to have complex, brittle acceptance tests everywhere, but unit testing is important to lower the risk of change and make your code more maintainable. Monitoring is not a substitute for testing. It's really important. It allows us to take on more risk. You need both of these things. You need monitoring, you need testing. You cannot just have one or the other, or else you're going to be having problems on both sides. Both are necessary. What's another old thing that we used to do that people are saying, oh, you don't need to do that anymore? Well, so clearly articulating dependencies is important if you're going to be running a really complex environment, right? Remember I said that monolith, you've got really complex application, relatively simple overall environment, and microservices is kind of the opposite of that. So it's good to know, like what service calls what. That's useful. New Relic can tell you some of that information. It's also useful, though, to have some sense of how to actually operate these services, because they're not all going to be identical. As much as you might want to automate and sort of make the process of making new services as similar as possible for different kinds of services, at the end of the day, your services are not all going to be identical. And you should actually, writing runbooks is a useful way to articulate those differences and those nuances about actually operating these systems. Enabling developers to hand off systems is good, because you cannot chain them to their desks and force them to support their systems in prod forever. There's this idea that developers should support their code in prod, which I completely agree is valuable. But we've got to be realistic about how far we can take that. Your developers are going to go on vacation. They're going to have babies. They're going to quit. And if you're in a microservices environment, you may not have very many developers who know each service. You may only have one who really knows each service. So you need to make sure that you can hand off these systems. I would say this is one of the big mistakes that I made early on, was thinking that this wasn't necessary. In fact, it's really, really valuable. So what about tools? A lot of people really get obsessed with tools. Microservices is cool because you can use all kinds of languages, all kinds of, the perfect back-end storage system for whatever your needs are for every service, right? Monitoring, oh, we want to monitor this thing this way, but this thing this other way, so we're going to have like 10 different monitoring tools. Be careful. Don't go overboard. Keep these proportional to the size of your development team, right? Developers are not actually very good at remembering how to use a whole bunch of things at once. Humans are not really good at remembering how to use a whole bunch of things at once. If you've got 10 different monitoring tools, for example, in production, and something goes wrong, probably the person who's on call may know how to use one of them, probably doesn't know how to use all the other ones. So they're now having to figure out, oh, what does this tool mean? What is it trying to tell me? I don't even know how to use this thing. All the while, there's a problem, right? Similarly, you're trying to build a new thing. Oh, well, I've got to use this special database to build this new product. Oh, so now I have to learn all the details about this special database. It slows things down if you go overboard with diversity before you actually have the development staff to support it. I am a big fan of consistency and clarity over creativity when it comes to things that are not core business problems for your environment. There are times in which things like monitoring may be a core business problem for your environment, but probably not when you're 30, 40, 50 developers. Probably when you're 30, 40, 50 developers, the core business problem is literally just making the product, making it scale, making it go. All right, part 2, understanding the state of the system at all times. The keystone habit here that great teams follow is that they are constantly looking at the data, right? It's pretty obvious. You go to a great company and you look around and there are monitors up everywhere with not only operational statistics, but also business statistics that are just constantly sort of being shared, being reflected, right? Your business, right, has trends. And if you immerse yourself and immerse your team in the data about not only what's happening with the systems, but what's happening with the customers, you start to identify those trends. You start to understand those historical trends. You want to keep record of that data. And you want to look at it. And you want to use it to intelligently make calls about what healthy looks like in your system, for example, right? Trends of performance or HTTP response codes. If those go significantly out of whack, you probably want to know about it. But also user behavior, right? If your user is behaving in a very different way, that's useful information. It may mean something's wrong, or it may mean something's very, very right. Understanding and immersing yourself in those trends is really important. Your most useful data is an approximation of your business. I originally gave this talk for a monitoring-specific conference, and what I was trying to say here was when you think about monitoring, often as engineers, we think about like the database or the databases as the most important thing. They're kind of the heart. I even think of it that way, right? They're the heart of my business. It's where all the information is, all the value is. So that's what I want to put as much monitoring around as possible. And it's true, you definitely need to understand what's going on there. But remember that your customers are in some sense actually the most important thing, the thing that you care about more than anything else, right? So understanding the rhythms of your business, understanding what your customer is experiencing, understanding what your web clients and your mobile app clients are actually experiencing. Because your systems may be broken and you don't know it, but it shows up because your customer isn't checking out, for example, or vice versa. Sometimes you're in a situation where your team is getting constant alerts or having constant problems, or even just frankly, your team is just constantly feeling like it's on the brink of things being broken. And your customer is happy. Your customer is basking in the flames that are burning you down, right? But your customer is acting as normal. They're continuing to do their business. And that doesn't feel great as an engineering manager. You feel bad. Your team is really suffering. But it's important to understand that balance, right? Your customer is the most important thing for your business. If you want your business to survive, your customer needs to be happy. And frankly, if your customer is still behaving as normal and your team is melting down, maybe it's not quite the 5-alarm fire that you're making it out to be. Okay, so we are trying to build a business here, right? We're trying to make our teams that can iterate and respond quickly. We are trying to make a business where we can really understand and see the data about our business and our systems at all times. And that is what we're doing to make our business successful in this new technology environment. All right, so to sum all of this up, we're all in this together. If you are in a modern stack, if you are in a future stack, whatever that exactly means, right? Hopefully you are here. Hopefully you're in that stack because you need to be in that stack. You have a good reason for doing it. You had a need that drove you here. We are in the early days of distributed application architectures, believe it or not. Even though there are already books having been written, and there are more books to come, I have no doubt, we are not there yet. We don't actually all have it all buttoned up with a bow, and you just have to follow these practices and you're done, right? There are some big players who have gotten here and have given us some ideas of where to go forward, but it's still very early days. We're all in the process of learning. We're all making mistakes. And so, coming to conferences like this and speaking to your peers, particularly if you are in one of those small businesses where you're learning and making mistakes, is incredibly valuable to kind of ground yourself in the truth out there, right? There's an underside to every age about which history does not often speak because history is written from records left by the privileged. This is from A People's History of the United States, right? And that's why I called this A People's History of Microservices, because often what you hear is really big players who have already got thousands of engineers, they've got hundreds of people on their tools and on their systems and on their automation, and they're doing everything perfectly, and they're telling you, oh, well, just do what I did. And you have 50 people, and you're like, okay, right? Just because you've got a small team and you're not doing everything perfectly, it's okay, really. You're probably doing the right thing as long as you're really focused on building your business. So, I lost my last slide, apparently. So I guess I was just going to sum this up in summation, right? We are all in this together. It's okay if you're not perfect. It's okay if you've got a mess somewhere that's kind of alerting and annoying you all the time, right? It's okay if you don't have a perfect DevOps culture, if you don't have a perfect automation story. It's okay if you don't use every single part of the quote-unquote modern stack. Take the parts you need, leave the parts you don't need, pick them up when you do need them, right? Take a breath, have fun, build your business, and please make sure your engineers are testing their freaking code. Thank you.
That was great. I can take the clicker and maybe we answer a couple questions. So Camille, that was wonderful. So unit testing, a must, a table stake, along with monitoring. Death stars are scary.
They are scary.
You imparted a lot of wisdom about microservices, which is a pretty common topic that we're engaging customers with, and I think a lot of people are confused. So your principles were very well laid out. I guess I'm going to ask you the hard question as the wrap here, which is if you were doing it again, entering into this era of microservices, and you know today, or you knew then what you know today, is there one piece of advice? I know it's very difficult.
I mean, the one piece of advice would really be to go a little bit easier on myself, because I think I was very hard on myself. But I think really practical, useful advice. Honestly, not to kiss up to the organizers here, but we wasted a lot of time having a million different monitoring solutions out there, and I kind of wish we hadn't spun our wheels so much because, I don't know about paying all this money for New Relic or whatever, and had just kind of not wasted a lot of developer energy and operations energy trying to set these systems up and use them. That actually was I think a true mistake that I made. I think we really spent a lot of energy trying to figure out our own story there when I don't know that was really the most valuable thing for us to be figuring out.
I heard you describing the paradox of choice, right? It's hard to make a decision when you have so many choices to make. So yeah. I want to credit you with a couple things. First of all, your ethically constrained approach as a CTO in growing a business. I love the way you articulated that as your vision. Love what Rent the Runway has done for all of us to understand a new economic model for bringing great fashion to women and men. No, not yet.
Women, unless they want to wear dresses.
Yeah.
We don't judge. That's totally cool. Whatever.
And I'm really looking forward to seeing what you do next. It should be really exciting. So thank you very much.
Yes,
really wonderful.
Camille.